Okay, we're back. Now, today I'm going to discuss another method of taking the inverse Laplace transform of a given function. This time we will be using the divide and conquer method, or what we know as 4B. Now, in our dialect, we call this one buka-buka and then bika-bika. Alright, so before we solve some complicated problems, let's try to solve some basic problems first. Let's start with 3s all over s squared plus 2s plus 10. So this problem, you can solve this problem. Oh, by the way, you can easily solve this problem by taking out. I'm going to take my laser pointer here. You can solve this problem by manipulating first the denominator. Take note, if you see this problem, try to manipulate first the denominator so that you will know what is the amount of shift in your denominator. So the amount of shift is very important later on. Now, to solve this problem, first we need to take out 3 outside your inverse Laplace transform sign. And then we are going to manipulate the denominator here so that I have a perfect square trinomial as a term in your denominator plus a constant term. So in this case, s squared plus 2s will become perfect square trinomial if we add 1 to the binomial. So s squared plus 2s plus 1 becomes perfect square trinomial. So we need to split 10 into 1 and 9. Okay, as I have said a while ago, we take out 3. 3 was taken out, no? And then we split 10 into 1 and 9. So why 1? 1 so that we can group this trinomial s squared plus 2s plus 1 so we can factor it out later on. So you have next thing to do is to group this one, the trinomial, and then factor it out. What's the factor of this trinomial? Okay, that is s plus 1 quantity squared. Okay, s plus 1 quantity squared. And in your numerator, you have s. In your denominator, you have s plus 1. Next thing to do is to make sure that all s now will have the same amount of shift. Meaning to say, if your denominator have s plus 1, make sure in your numerator, which is s here, becomes s plus 1 also. By adding 1 and subtracting 1 to your numerator, this will become s plus 1 minus 1. Okay, s plus 1 minus 1 is just s all over s squared, s plus 1 squared plus 9. Take note, we added 1 to your numerator and subtracted by 1 later on so that the amount of shift in your numerator will be the same as the amount of shift in your denominator. After this, we are going to separate the two fractions, meaning we will separate s plus 1 all over this denominator minus 1 all over this denominator in your next slide. So in your next slide, the fractions are separated. This will become s plus 1. This will become s plus 1 quantity squared plus 9 minus 1 all over s plus 1 quantity squared plus 9. So can you still recall what form is this in your transformation table? Right, this form follows the sign bt, the Laplace transform of sign bt. But in this case, the numerator here is missing a number. What is that number? Take note, this is s squared plus b squared. S squared plus b squared. So we have b squared here, and there should be b in your numerator. So if this is 9, your numerator becomes 3. So since we don't have a 3 in our numerator, we need to multiply this by 3 and then divide it by 3 in your next expression. So I will multiply 3 to the numerator and divide it by 3 so that this term will follow the Laplace transform of sine bt. So here is the Laplace transform of cosine bt, but s here is shifted by 1 unit. Now, next thing to do is to take the inverse Laplace transform of each term. Now, if we will distribute the inverse Laplace transform to each term and then take out the amount of shift by 1 unit, so if we are going to take out 1 and 1 here, that becomes exponential function outside the inverse Laplace transform sign. So we will take out 1 and then that becomes e raised to minus t. So if you are going to take out 1, okay, I'm going to use my pen. If I'm going to take out 1 here and then 1 here, that becomes e raised to minus t outside of the inverse Laplace transform sign, leaving you this term without shifting. So this is s all over s squared plus 9. The same is true if we are going to take out 1 here. So if we are going to take out 1 here, outside your inverse Laplace transform sign, this will become e raised to minus t, leaving you 3 all over s squared plus 9. So if you are going to take the inverse Laplace transform of this, what is that? Yes, that's cosine of 3t. What about this one? What is the inverse Laplace transform of this? Right, that is sine 3t. Now, that becomes 3 multiplied by e raised to t multiplied by cosine 3t minus 1/3 multiplied by e minus t multiplied by sine 3t, okay, enclosed with a bracket. And then what are we going to do next? We need to multiply this. We need to simplify it further so that becomes 3 multiplied by e raised to minus t multiplied by cosine t. Take note, we distributed 3 no, in each of the terms. So multiply 3 to each of the terms here so that it will become 3 times e raised to minus t cosine of 3t minus 3 times this 1 over 3 becomes negative 1 e raised to minus t and sine 3t. Okay, any questions? Feel free to comment on this video for your questions. I will be glad to answer your questions. All right, now for your next problem. This will be our next problem. 2s minus 4 all over s squared plus 6s plus 25. All right, now the first thing that we should do here is to factor out your numerator and then try to think of splitting this 25 into two parts. Make sure that one part will be added to this binomial to make it a perfect square trinomial. What should be that number? What should be the number that will be added to s squared plus 6s so that it will become a perfect square trinomial? Correct. It's 9. So if I'm going to split 25 to 9 and 16, okay, this is the splitted number, 9 and 16. Take note, we factor out 2 and take that out in your outside your inverse Laplace transform sign. This becomes a perfect, okay, I'm sorry. This becomes a perfect square trinomial. And how are we going to factor it? So we can factor the perfect square trinomial, okay, by squaring it. Take note, no? S plus 3 quantity squared is just the same as s squared plus 6s plus 9. Okay. Now, what are we going to do with your numerator? Take note, your numerator here is initially s minus 2. Our goal here is to make your numerator s plus 3. to make that numerator becomes s plus 3, we need to add 3 here and then we subtract 5. Why do we need to subtract 5? So that 3 minus 5 becomes 2. Okay? Now, the next thing that you should do is to split the fraction. When you split the fraction, okay, in your next slide, here, the fraction was splitted into two parts. I have here s plus 3 all over s plus 3 quantity squared plus 16 minus 5 all over s plus 3 quantity squared plus 16. Take note, this this term, no, is actually the Laplace transform of the sine function. Okay, but what is missing here? If your b squared is equals to 16, what should be your numerator here? Okay, 4. So 4 should be your numerator here, not 5. So what are we going to do with 5? You take it out, multiply that by 4, and then divide that by 4. That will become s plus 3 all over s plus 3 quantity squared plus 16 minus 5 over 4 times 4 all over s plus 3 quantity squared plus 16. Take note, 4 and 4 is just 1. Okay, so if that is equal to 1, um, your your term here is not changed. By the way, I deleted all the markings. Okay, so 4 and 4 is just 1. So 1 times 5 is 5. That is why we need to do this, because I want this second term to be the same in the form of the same as your Laplace transform of sine bt. Next thing to do is to take the inverse Laplace transform of each term. Now, if you are going to take the inverse Laplace transform of this term, the first thing you should do is to take out the amount of shift. So the same is true with this second term. You take out the amount of shift. So by taking out the amount of shift, will actually becomes e raised to minus 3t. That is outside your inverse Laplace transform sign. The same is true with this term. This will become e minus 3t. Now, if you will notice, s here become s plus 3 in your numerator becomes s because the amount of shift was taken out. S plus 3 quantity squared becomes s squared. The same is true with the second term. S plus 3 becomes s squared because the amount of shift was taken out. And then the next thing that you will do is to take the inverse Laplace transform of that term. And we already know what is the inverse Laplace transform. What is that? Okay. That is cosine of 4t. What about this one? Right, this is sine of 4t. So leaving you to all multiplied to e minus 3t times cosine 4t minus 5 over 4 times e raised to minus 3t times sine of 4t. To simplify this uh, terms, we need to multiply, we need to distribute 2 to each of the terms. So multiply 2 to e raised to minus 3t, that becomes 2 times e raised to minus 3t cosine of 4t. Multiply 2 to 5 over 4, that becomes 5 halves e minus 3t sine of 4t. That will be your final answer. Alright, let's have another example here. Assuming I have here 2s plus 8, that is divided by s squared minus 4s. Now, take note, your denominator is lacking a number. To make it a perfect square trinomial, what should be added to your denominator? What is added? Okay. I will teach you how to do that. The first thing to do is to take the square root of that. What is the square root of s squared? Write s. And then, multiply that by 2. That will become 2s. Then divide this by 2s. What's the result? negative 4s divided by 2s. What's the result? 2. Okay? The result is 2. Then square 2. What's the result? 4. Yes. 4 is actually the missing number there. So we need to add 4 so that no, it will become a perfect square trinomial. So I will erase all the writings and then proceed to the next line. Okay. Our first no our first step is to factor out your numerator, which is 2, and then find a number that will be added to your denominator. So that is 4. Okay, let's review. Square root, that is s. Multiply that by 2, that is 2s. Okay, this minus 4s will be divided by 2s. That's negative 2. Okay, negative 2 squared becomes 4. So if you are going to add 4 here, no, minus 4 here, that is actually adding 0 to your denominator and it does not change your denominator. Why did I add 4? Because I want to make my denominator a perfect square trinomial. So that will be s squared minus 4s plus 4. No, I grouped that into one term and then later on I factored it out. That will become s minus 2 quantity squared minus 4. Now in your numerator, take note, in your numerator, this is 4. Okay, this is s plus 4. But we need to balance your numerator by the same amount of shift. That is why your s in your numerator is subtracted by 2, just like in your denominator. Then when it is subtracted by 2, I added 6 so that this this will be equal to 4. Minus 2 plus 6 is just equal to 4. So the purpose of that is because we are going to separate the two fractions. Okay, when we separate the two fraction, okay, this will now become s minus 2 all over s minus 2 quantity squared minus 4 plus 6 all over s minus 2 quantity squared minus 4. Now, in this term, we need to change the value of 6 here. What should be the number there? Right, that's 2. So 6 is actually um, 6 is not the number here. Now, if we will make 6 equal to 2, we factor out 3. So factoring out 3 no, to the number, take note, no, we distributed the inverse Laplace transform sign because we want to take the Laplace transform sign, the inverse Laplace transform of each term. Okay, taking out 3 outside your inverse Laplace transform sign, if you will notice, this is the inverse Laplace transform sign. I take out 3 to make this 2 so that this will become the same as in the form of your hyperbolic sine function. This is the same as in your hyperbolic function. Okay, if you can still remember your transformation table. Now, the next thing that you will do is take out the amount of shift, which is 2. Wait, the same is true here. Take out the amount of shift, which is 2. That will become e raised to minus 2t. Now, if we are going to take out the amount of shift, which is 2, we are going to put that outside the inverse Laplace transform sign. It will become e raised to 2t. That will leave you s in your numerator and s squared minus 4 in your denominator. The same is true with your second term. We have 2 all over s squared minus 4. Now, the next thing that you will do is to take the inverse Laplace transform of that. And what is that? Okay, the inverse Laplace transform of s all over s squared minus 4 is just cosine hyperbolic of 2t. And the inverse Laplace transform of 2 all over s squared minus 4 is just sine hyperbolic of 2t. Multiply that by 3 minus 2t, all multiplied by 2. Now, to simplify it further, you are going to distribute 2 to each term. Okay, that will give you 2 e raised to 2t cosine hyperbolic of 2t times 6 plus 6 e raised to 2t sine hyperbolic of 2t. That will be your final answer. Now, it's your turn. I want you to get a piece of paper a ball pen and then try to solve this problem. What is the inverse Laplace transform of 3s minus 12 all over s squared minus 6s plus 34? Alright, I will give you 10 minutes to answer this problem. Don't forget to pause your video for a while, answer the problem. Now try to test yourself if you are learning, no, on this new lesson. Okay, okay, 10 minutes is over. Okay. Are you ready to uh, see if your answer is correct? Of course, your final answer should be 3 times e raised to 3t cosine of 5t minus 3 over 5 times e raised to 3t times 5 sine of t. This will be your final answer. Did you get it right? Oh, yes. Now let's try another one. I have here the inverse Laplace transform of 2s plus 4 all over s squared plus 18s plus 77. Try to solve this problem for 10 minutes only. Alright, okay, 10 minutes is over. And the final answer would be, charan, 2 times e raised to minus 9t multiplied by the hyperbolic cosine of 2t minus 7 times e raised to 9 minus 9t multiplied by the hyperbolic sine of 2t. I hope no, you get it right because this is very important in your practice. Try to practice while watching the video.